naming organic compounds. So let me start with a simple compound. I'll be using skeletal formula. So let's look at this one. So primarily, the first step when we're naming any organic compound would be to number the longest carbon chain. And let's go ahead and let's number this chain, shall we? So that'll be 1, 2, 3, 4, 5, 6. So that's six carbon atoms. And recall that in any scalar formula, any end or a corner is skeleton that represents a carbon atom. So I have a carbon atom here, a carbon atom here, carbon atom here, carbon atom here, carbon atom here, carbon atom here. So total I have 6 carbon atoms. We go over to my table on the right here. Let's look at what prefix that corresponds to. So 6 that corresponds to hex. It's going to be hex. And since I'm dealing with an alkane here, that's simply going to be hexane. Let's move on to a bit more different example. Let's try cycloalkane this time. So let's go ahead and number this so that I find the longest carbon chain. So it'll be 1, 2, 3, 4, 5. It will be in the form pent. But since we're dealing with a cycloalkane and not an alkane, this would be cyclopentane. Okay, so let's move on to a slightly more complicated, slightly more different example where we deal with branches. Go ahead and let's try to number this carbon chain. But something to note here is that when I number this carbon chain, I'm going to number it in such a way that I get the lowest possible number on this branch. So let's go ahead and number it. So I'm going to number it from the left. Let's see what number I get on that branch. So it will be 1, 2, 3, 4, 5. But wait, I could number it from the right too. And let's see what number I get on that branch. So I'm going to use a different color. 1, 2, 3, 4, 5. So since I'm getting a number of 2 and I number it from the left hand side, I'm going to go ahead with 2 because that's a lower number. So let's use the tool. Now we have to identify this group. So since I'm dealing with one carbon atom in our group, so this is my group. This here it's a methyl group. Since it has 1 carbon, if we had 2 carbon atoms, something like this CH2, CH3, that's an ethyl group. In our syllabus, that's the highest we go. We only talk about methyl and ethyl. We don't go forward into propyl because that complicates things a bit more. So let's try to figure out what name our compound has. Okay, so that will be 2-methyl, and we have 5 carbon atoms in the longest chains. That will be 2-methyl pentane. All right, so let's move on to it. So as you can see in this formula I've drawn, we have 2 different groups. Let's forget about it and let's try and number our carbon chains that we get the lowest possible number. So my gut tells me that I'm going to number it from the right. So if we go ahead, so on the second carbon atom I have a methyl group, and to the third carbon atom I have an ethyl group. Let's name that compound. That will be 3-ethyl 2-methyl. Since there are 5 carbon atoms on a longer carbon chain, that will be a pentane. And notice that I 1, 2, 3, 4, 5. So notice if I number it from the left, the 2 carbon atoms attached to the group, they'll get a number of 3 and 4. So I'm going to go ahead with 2 and 3 because those are the lowest possible numbers. So let's try and analyze what groups we have here. I put that before the metal. And there's a reason for that. That's because when we have multiple prefixes, we want to order them alphabetically. So there are four on the bottom, that name where we have metal in front of ethyl. That's wrong. I'm sorry, I don't make the rules. IU practice. So so we sort of obliged to follow them. They might seem tedious at first, but with a bit of practice, you tend to notice the pattern. So that's it for this video.